In this video, we are going to talk about how to calculate the volume of prisms and cylinders and go through some examples where we actually calculate those volumes. In the previous video, we went through some demonstrations to kind of explain where these equations are coming from, and we learned that the formula for volume of a prism and cylinder is V equals capital B times H, and that capital B is representing the area of the base, and the lowercase h represents the height of the prism. I want to remind you guys a key fact, which is that height is always going to be perpendicular to the bases, right? So if we look at these pictures here, this is my base, and so this is my height. This is my base, so these edges are my height. It is really important to notice that that height is going to be what connects your two bases in a prism. So let's look at some examples. So this first one, we have what we would call a triangular prism because the base is a triangle, and we are going to calculate the area. So to do this, I need to know B and I need to know H. Well, we know that H, remember H is our distance that connects the base. H is going to be 15 feet, but we do need to calculate B. So if I look at my base here, I know that this edge of the triangle is 12, and I need to calculate B. So I know that I have a triangle, and area of a triangle is 1/2 base times height. So I need to know those two edges. Now they tell us it's a 30-degree angle, so you could use trigonometry or you could use special right triangles to get that base and that height. I'm going to use special right triangles, and so we're going to know that this edge is 6 and this is 6√3 because it is a special right triangle. So I can do area is 1/2 times 6 times 6√3. And if I take out my calculator, I can do 1/2 times 6 times 6√3. Because I am in the middle of my equation, or in the middle of my problem, I am going to leave an extra decimal place, so I am going to leave 3 decimal places, and we're going to have that the area is 31.177. So now that we know our base and our height, we can calculate our volume. So volume is BH, which will be 31.177 times 15. And so I can take my calculator again and do 31.177 times 15. And we get that the volume is about 467.66. So that's 467.66 cubic feet, because volume is done in cubic units. And you notice that I left 2 decimals in my final answer. Now, I love this formula because it will work for any prism that you have, and you don't have to now memorize all these different types of formulas, because we do know how to calculate the area of a lot of different figures. Let's go through one more example that we will do completely together. So now we have the volume of a cylinder. Once again, we know that volume is area of the base times the height. And they do ask us to leave our answers in terms of pi. So like we did with sector area and arc length, we will not be multiplying by pi as we do our calculations, and we'll leave it like we would leave an x when we're combining like terms. So we know that our height is 15 inches because it's the segment that connects our two bases. To get the area of the base, we know the base is a circle. So we can do area of a circle is pi r squared. And we know the radius, in this case the radius is going to be 6 because it is half of the diameter. So I'm going to do pi times 6 squared, which would give me 36 pi. You notice I did not actually multiply by pi or an approximation of it because I want to leave my answers in terms of pi. So now that we have our volume, or we have our height and our base, we can calculate our volume by doing volume is 36 pi times 15. To evaluate this, I'm going to take my calculator and do 36 times 15, and we get 540. So our volume is 540 pi, and even though we're leaving it in terms of pi, we still need our units, so our units are cubic inches. So these are two examples where we calculated volume. In both cases, we had to calculate the area of the base, and sometimes calculating the area of the base will require us to use some of the math that we've already learned, right? We had to use special right triangles in this case. In the second problem, we had to know that the radius is half of the diameter, and you do need to know your formulas for area. But it's okay if you need to go back and remind yourself of some of those formulas. I'm not expecting that every single one you have memorized. So in this problem, we could think of this one in two ways. You could see a parallelogram prism, or you could see it as an oblique rectangular prism, because it is a rectangular prism that has then been shifted a little bit, so it's at an angle. Either way, the formula is going to be the same. If we treated it like an oblique rectangular prism, then the base is that side I highlighted, that rectangle with edges 10 and 15. Well, if this is my base, then I can calculate the area by doing 10 times 15, and we know that the area is 150. And then we know that the height of any oblique prism is going to be that perpendicular to the base, so it is going to be 12 feet. I want you to notice that you didn't have to actually change anything to get the height. The height is always perpendicular to the bases. So now that we know the area of the base and the height of our oblique prism, we can calculate our volume. To calculate our volume, I'm just going to do volume equals BH, which will be 150 times 12, and I can take out my calculator to help me if I need to. We've got 150 times 12, which is 1,800. So that is 1,800 cubic feet. So the two things I want you to see here, there are actually two different ways you could do this problem. You could identify the rectangle as the base and then treat it as an oblique prism, or identify the parallelogram as the base and then use the height of 15. Both of those would totally work. The other thing, just like when we were doing area, height is always going to be perpendicular to the bases, right? So I have to be looking for this value here to get my height. We can do another example. In this case, we have a trapezoidal prism. So the first thing we're going to need to do is identify that our formula is BH, area of the base times the height. What is the height in this case? In this case, the height is going to be 6 centimeters, because that is what is connecting our two bases. Remember, your bases should make congruent slices throughout your figure. So if we're looking at this prism, you can't take the rectangle as the base, because that rectangle is not congruent all the way up our figure. It's only the trapezoid that's going to create those congruent slices. So then we can calculate the area of our trapezoid. The area of our trapezoid is going to be 4 plus 2 times 1.5 divided by 2. That is our B1 plus B2 times the height divided by 2. That would be 6 divided by 2 is 3. 3 times 1.5 is 4.5. So now our volume is going to be 4.5 times 6, which will give us 27 cubic centimeters. And we can do one more example. So in this example, we have a hexagonal prism because the base is a hexagon. So to do our volume, which is area of the base times the height, we're going to have to calculate the area of this hexagon, which is not the easiest thing that we've learned in this class. It does take a couple of steps. You notice that I drew the base separately to help us with calculating that area, and we know the side is 4. We also know that the height of this prism is 16 meters. So if we're going to calculate the area of this hexagonal prism, we're going to use our formula. Area is 1/2 ASN. You might need to go back in your notes to review how to calculate the area of a regular polygon. I know this side is 4, and I know that there are 6 sides, but I do have to calculate my apothem. To calculate our apothem, we're going to have to use this triangle here and do some trigonometry. To calculate that triangle, I'm going to need to know this angle up at the top. That angle up at the top, we're going to do 360 divided by 6 gives me 60 degrees. And then I'm going to do 60 divided by 2 to get that this angle right there is 30 degrees. So now we have this triangle with 30 degrees to an A. You notice that I took that half of the side because this triangle is only using half of the side of our prism or our polygon. And we could do special right triangles or trigonometry, but you're going to get that the apothem is 2√3, and if we took our calculator, we could approximate that as 2√3 is about 3.464. If you did trig, you should get 3.464 as well. So now we can calculate our area is 1/2 3.464 times 4 times 6. So we can do 1/2 times 3.464 times 4 times 6. And we get that the area is 41.568. And then we can calculate our volume as 41.568 times 16. So I can just take that answer, multiply it by 16, and our volume is 665.10 cubic meters. So our volume is 665.10 cubic meters. So I want you to notice what's important in these problems is being able to accurately calculate the area of those bases, and you might need to go back and practice some of those area problems to be able to calculate your volumes. Thank you guys for watching.